Hello friends, let us move on a chapter 2, unit 2, a 1D element. In this lecture we are studying a displacement function, types of the coordinate system and the shape function. I have already mentioned that we need to understand the first of all the displacement function in a right way and as well as the types of the coordinate system. Once we are understanding these types of the coordinate system and displacement function in a right way, then there is no difficulty to solve any type of the problem into the finite element analysis. Again, here we are not calculating the shape functions, but we are trying to find out what are the different properties are required for the shape function. So let us move first of all on the displacement function. So displacement function, we know very well that there is the element and this element may be applied with the different types of the forces. So there is a possibility now, let us take this is the element, and this element is applied with a certain force on this one. So let us take this is the one element and the force applied in this direction, the force applied in this direction, or the force is applied into this direction. So when we are applying the forces into these two directions, then there is a elongation taking place. So elongation, so there is a possibility that whatever the values of this one is elongated into this direction, as well as there is a possibility this one is to be elongated into this direction. So whenever this one is to be elongated into this direction, that time there is a displacement taken place. So how to calculate this displacement is very important. So this displacement is calculated mathematically, called as the displacement function. So finite element analysis is a very important tool for solving the complex engineering problems. It is used for the many purposes or the many areas, that is civil, structures, aerospace, automotive, heat transfer, fluid. So each one is dividing the complex geometry into a finite elements and then finding the different types of the loads and material properties, and lastly they are trying to find out the solve the simultaneous equation. So here I am interested into the displacement model. So whenever I have already mentioned that now there is the whenever the force is applied, displacement taken place. So this displacement is calculated by two methods. So the discretized geometry gives the number of nodes. In a finite element analysis, we obtain the solution at the different nodes, and these nodal displacement are called as the displacement function. So this nodal displacement means this node is displaced by a certain distance, that is called as the nodal displacement, and that is called as the displacement function. So these displacement functions are calculated, or this displacement models, or there are the two types of the models. One is called as the generalized displacement model and the second one is the interpolation function model, or we could say that directly just a displacement is calculating with the help of the generalized displacement model and the interpolation. Second one is the interpolation model. Now the generalized displacement model. This is very simple model, or this is the majority times, or we could say in a chapter number 1, 2, and probably into the 3 also we are using this generalized displacement model to solve the all type of the problems in a 1D, 2D parameters. So what is that? The generalized standard displacement matrix is this one, that is the stiffness matrix multiplied by your delta, means the displacement matrix is equal to force matrix. This is the very simple form of the matrix displacement equation. What is this? The K is the displacement matrix, delta is your displacement matrix, and F is the force matrix. So F is the force vector, K is the stiffness matrix, and the delta is the displacement vector. We need to find, whenever we are solving any problem, that time we first of all we need to find out the force vector, then we need to find out the stiffness vector as well as the displacement vector. Generally displacement is the final solution. We need to find out how much displacement is taking place, but to find out this displacement we need to find out first of all the stiffness matrix, and this is the very important concept to find out the stiffness matrix. And once we are able to find out the stiffness matrix, then that is very easy to solve any type of the problem into the finite element analysis. So the stiffness matrix, you need to focus that, yes, how to find out the stiffness matrix, and this chapter is related with the stiffness matrix calculation. So be attentive for the whenever we are doing a study of a stiffness matrix. Second method is the interpolation method. Now What is that interpolation method? There is a change into the formula. Here we have considering delta is here. So this is the very simple equation, and through this equation we are trying to find out the solution to find out the displacement. While here the formula for the interpolation function is the u, that is the displacement, is equal to your shape function multiplied by your nodal displacement function. So what is that? That is u is equal to shape function and nodal displacement function, means the force is equal to that is the u is equal to force, u is equal to force is equal to shape function multiplied by your nodal displacement matrix, now. So whenever we are interested to find out the displacement, there is the method 1 and the method 2. So in a method 1 we are interested to find out first of all the stiffness matrix, while in a method 2 we are interested to calculate first of all the shape function. So once we are able to find out the shape function, by putting these values of the shape function, we can very easily find out the displacement or the forces required for this one. So for example, let us take this is u is equal to, if there are the two elements n1 x1 plus n2 x2. So n1 n2 are the isoparametric shape function and x1 x2 are the displacement coordinates within the element. Now let us take this is the problem of a temperature. So this is the temperature calculation. So that is the temperature at a point q. So temperature at a point q is equal to shape function multiplied by temperature, so again this is the shape function multiplied by temperature, and this one is the point where we are interested to calculate a temperature. That's why there are the nodes, node 1, node 2 and node 3. So whenever we are thinking about this one, so node 1 and node 2, this is the node 1, this is the node 1, this is the node 2, this is the node 2 and this one is the node 3. So there are the three nodes. So the elements are number of nodes minus number of nodes minus 1. So this is the element 1 and this is the element 2 is available. That's why whenever we are calculating the temperature at point q is equal to addition of the two elements, so n1 t1 plus n2 t2. So this is the methods just to find out the displacement of a model. You keep in your mind, whenever we need to find or whenever we need to try to solve the problem, we need to focus first of all what type of the displacement model we are using. If we are using a this matrix, that is the standard displacement matrix, then we are focusing on a stiffness matrix to calculate the stiffness matrix, and whenever we are using the interpolation function, that time we are focusing on the shape function. So whenever when we are moving to a chapter number 4, that is the isoparametric elements, that time we are focusing mainly on the shape function, because in that chapter the shape function playing the important role, and we are using this equation, displacement equation, into that chapter. That's why we are trying to calculate the shape function in a chapter number 4, not into the chapter 1, not in a 2, not in a 3. But here we are focusing just to calculate the element stiffness matrix. This is the very important concept for this one. So let us move first of all a coordinate system. Again, the very important concept, that is global coordinate system, local coordinate system and the natural coordinate system. Now what is this? So you knows very well a local coordinate system. Let us take the example of a one person or one student is watching a star from the Kopergaon. So his dimensions to watch that star is different, and if the same person moves to the Delhi, and from that Delhi if he is watching a same star, then there is a change into the coordinates. So ultimately when the coordinates are changing, or that one are with respect to that particular point, then that is called as the local coordinate system. Let us take this is the example, this is the diagram. Now let you know you are very comfortable with the three-dimensional diagram. This is the x axis, this is the y axis and this one is the z axis. So this is the z axis. So whenever we are drawing such a axis system, that is the x y z axis system, that is called as the global coordinate system. but this is not the local coordinate system. This is not the local coordinate system, because it one is not representing a local coordinate system, representing a local factor, local parameter, while the global coordinate system is applicable globally. It one is useful for anyone. So whenever we are interested to define the any point here, so I need to interpolate the parameters through this one, and accordingly I would be able to write this here. The dimension x is 1 and the y is 2 or 3, like this one, 2 or 3. So whatever this parameter I'm writing here, that one is the two-dimensional parameter. So this figure is suggesting me a difference between the global and local. Now just still I am not feeling that just you are comfortable with this one. So here you can see this is the x-axis. Now for this one, this is my x-axis, this is my y-axis, and this is my z-axis, 90 degree to each other, 90 degree to each other. So what is this? This is my x-axis, while this one is my global x-axis. This is my global x-axis, and this is my local, because this is my point. Here I am standing, and through this one I need to find out my parameter. So along this one, this is my x-axis, this one is y-axis, this one is z-axis. So this is my x-axis, and this x-axis is called as the local coordinate system. And whenever I need to represent, I need to apply a cap, or sometimes it is called as the hat. So when a any variable is written, and above that one if there is a cap, then that is called as the local coordinate system. This is the local coordinate, while here only the x is written, then that is the global. So my main intention, first of all, to understand what is meant by the local and the global coordinate system. So with respect to that point, a person watching or the particular point, if you are defining your dimension system, then that is called as the local coordinate system. And this local coordinate system is represented with a cap, variable with a cap. This one is the y, then this is the z cap. So when I'm given the cap, then that is the meaning of that. This is the local coordinate system. And when on a variable there is no cap is available, then that is called as the global coordinate system. Global, it is the globally accepted dimensioning system, and the local is at a particular point. But when we are looking towards this type of the global coordinate system, then what we observe? We observe that is this is the 0 point, this is the 0 point, and it will needs to be elongated to the infinity. So if this one is elongated until the infinity, then for the manipulation, for the calculation, there is a lot difficulties we are facing. So, and computer required a lot memory, or as well as it takes a more time to calculate that one, because this is the infinity, this is the infinity. So along the x-axis we can move up to the infinity, along the y-axis we can move up to the infinity, along the z-axis we can move up to the infinity. So ultimately the computer takes more time to calculate to manipulate the infinity. So best way, instead of that one, we are using the third coordinate system, and that is called as the natural coordinate system. So in natural coordinate system, the end point is 1. So natural coordinate system is in between +1 and the -1, and all other dimensions are lying in between this one. Since this one is lying between the -1 to +1, -1 to +1, this is very easy to manipulate a calculations in a computer system. So there is a third coordinate system, that is called as the natural coordinate system. In a natural coordinate system, we are considering the coordinate system within a limit of the -1 to +1. Hence the local coordinate system is this one. This is the local coordinate system, this is the local coordinate system, this is the global coordinate system, and this is the natural coordinate system. Natural coordinate system is lying between -1 to +1. That is the natural coordinate system. When globally accepted parameter, then that is called as the global coordinate system, and the local coordinate system is with respect to your own point. When you are drawing the your coordinate system, then that is called as the local coordinate system. Now these are very important for every problem. If we are taken the dimension along with your natural coordinate system, and if you want to measure this local point, measure this local point on this global parameter, then there is a need of the transformation. So we need to transform this local point P, local point P on a global point, on a global point. So there is a possibility. Now if I looks towards this point, then if I want to check from this point to this one, okay, now this is my coordinate, local coordinate system. From this local coordinate system, there is a possibility this dimension is offered to, is offered to, is at a distance of a 2. But if I transform this local coordinate to my global coordinate, and if distance is more than again 2 or something, then this is not a 2. So this one is the 2, or this is the sign of yes, cos of 2 cos theta, 2 cos theta, 2 cos theta, or we could say that this is the 4 cos theta, 4 cos theta. So this distance is a 4 cos theta. So I am transforming my x-axis, I am transforming my x-axis from the local to a global, by a transformation matrix, by a transformation matrix. So this is, that's why this the coordinate system are very important from the study, for the study. Hence always keep in your mind what is meant by the local coordinate system, what is meant by the global, what is meant by the natural coordinate system. So if there is a local coordinate system, we need to transform it on the global coordinate system. Similarly, a global coordinate system and the natural coordinate system, there is a certain relationship. So you can see in a one-dimensional figure. Now this is the global coordinate system, this is the global coordinate, this is the one is 1, this is the point for the for importance, and this is 2. So the element 1 and 2, while this is my global system, this is the x-axis and this is my y-axis. Now since this is the one-dimensional problem, that's why this one is to be shown here. So up to 1 there is the x1 up to my reference point, that is the q, that is the x q or x0, and at the node 2 this is the x2. While in a local coordinate system, we consider a element only, we consider the element only. So at x1 that is equal to 0, then at this point, whatever the point, that is p, is important for 1, that is xq is equal to x, and x2 is equal to length, whatever the length is considered. So this, if this is the length is considered, then if this is the length is considered, then that is x2 is equal to l. So this is the local coordinate system. The element itself is defining its points. In global, the this is the 0. From the 0 we are considering these parameters, and the third one, that is the natural coordinate system. So in a natural coordinate system, that xi is between -1 to +1, -1 to +1. So my point of reference, if this is my, if this is the 0, and if this is my point of reference, so if xi is here 0, and this is the my point of reference, so this is by a figure of a 0, sorry, xi. So this is the point of a reference. So this is again, I could say this is the q, this is the point where I need to calculate the q, and this is the point is a q, is the point is of a q. Now we are interested to find out the relation between these two parameters, natural coordinate system and the global coordinate system. So that q1 is equal to 0, q x0 is equal to x and x2 is equal to L, the relationship between the global and the natural coordinate system. So x1 is equal to 0, so x1 is equal to 0. Now look here, that is x1, this is the x1 is equal to 0. Okay, x1 is equal to 0 here, this is the x1 is equal to 0. Then x0 is equal to x and x2 is equal to L. x1 is equal to x and x2 is equal to L. So we need to manipulate this one. So that is that the relationship is developed that the dimension of an element in a natural coordinate system divided by the dimension of the element in the local coordinate system is equal to distance of a point q from the node 1 in natural coordinate system divided by the distance of a point q in a from the node 1 in global coordinate system. So that is the dimension of an element in natural coordinate system is 2 divided by local coordinate system, that is the x2 minus x1, hence is equal to that is distance of a point q from the node 1 in nq. So here you can see this one is the this one is at a, this is my point important, this is the very important point where I am interested to calculate my relationship. So this is equal to xi plus 1. So this is the xi, this is the distance xi, and this one is the plus 1 from this 0 and this is the minus 1, so that is equal to plus 1. So xi plus 1 is to be considered here, hence xi plus 1 minus divided by x0 minus x1, hence xi is equal to 2 multiplied by 2 multiplied by this term moves to here, this term moves to here, so x0 minus x1 divided by x2 minus x1 minus 1, this plus is here, so that one moves to here, so minus 1. So this relationship is developed, and in this way we can very easily find out the value of a xi. Let us move on to one problem. So this is the problem, now here what they have given, that is the element at a distance of the 200 and 300 respectively, and from the local point this one is at a distance of a 40, at a point of a 40. Okay, so this is, and xi is this point P is here. They are interested to find out the natural coordinate, at the same time they are interested to find out the shape function and the displacement also. So let us move. First of all, what they have given, they have given that from this distance to this distance is 200, up to this one 200, then this one up to this one, this is 360, this is 360, and this distance is 40, this distance up to point 40. So these parameters are given, and they are asking to find out the value of xi. They are interested to find out the value of xi, that is the natural coordinate. So this xi, they are interested to find out the value of xi. Now how to solve this problem? A very simple one, just put the formula. This is a very important formula. Through this one we can very easily find this one. So 2 is common, so 2 divided by multiplied by x0 minus x1. So what that x0, that x0, what is there, what is that x0 is given, this is the x0, this one to this one, x0 minus x1 so x0, what is this x0, is given, that is this one, this distance minus this one. So first of all we are interested to find out what is this x0. So x0 is equal to first of all this distance is 200, so this is the 200 plus this point, up to this point, this is already 40 is given, so that's why this is the 200, that is equal to 200 plus 40 is equal to 240. Hence here we put this one 2 multiplied by 240 minus 200, divided by what is this? That is x2 minus x1. x2 is 360 minus 200 minus 200. So we are getting that value xi is equal to minus 0.5 minus 0.5. So this is the very easiest way to find out the value of a xi. Then we are finding the shape function by putting the simple formulas into this one, and we are calculating that a shape function. Similarly, the displacement is also calculating, that is u is equal to, that is displacement function multiplied by distance, displacement function multiplied by distance. So the displacement function, shape function we are calculating, displacement function also known to you, hence we can very easily find out the displacement. So this is the method just to find out different types of the relationship between the natural coordinate system and the your um, global coordinate system. Now these are the certain um, properties of the shape function. Into these properties, the important properties are these three, that is the interpolation property, then the local support property, and the inter element compatibility property. I have already telling you that whenever we are interested to find out the displacement function, two methods we are using. One method is the stiffness method and the another one is the shape function method. So in a shape function we are interested to find out the shape function. So whenever we are calculating the shape function, that time these three properties to be maintained very perfectly. So shape function that have the unit value at the node. So if I have taken the element this one, so if the shape function at the node this one, if this shape function is of a size 1, then at the another node it must be 0, it must be 0. So if I draw a shape function line, then it should be look like this one. So at this one the value is 1, and at the another node it should be 0. So that is called as the interpolation property. It shows that the shape function should have the unit value at the node 1, under consideration, and the value 0 at the second one. The shape function should vanish over if boundary which does not contain the node under consideration. If the boundary condition is here, so that one is not to be considered, because this is not the part of a element. And the certain third one, that is the inter element compatibility. So the continuity is required. If I am interested to find out the value here, then these two elements, these two nodes must be connected to each other. If these two nodes are not connected to each other, we could not be satisfy the shape function property. It means that this should be a continuous element. If it one is break here, then the shape function will begin from this side. So we could not consider this as a node. So there is a need of the continuity of an element, that is called as the compatibility property of a shape function. Then last but not least, a primary and the secondary variable. What is that primary variable? So we are interested to find out the different solutions. So whatever the solutions we are interested to find out, that one are the primary variables whose values will be calculated directly from the shape function equation. Or we could say that the values we are finding by solving the primary finite element analysis directly, that is called as the your primary variables. This is also called as the field variable. Sometimes it is called as the field variable. So those are directly calculated from the shape function or the stiffness function, that is called as the primary variable. While secondary variable that are indirectly calculated, just like if we are calculating the force, displacement is obtained by solving the algebraic equation. So this is the primary. While the stress or strain are expressed in terms of the nodal values of the primary variables, then that is called as the secondary variables of the field, or secondary variable of a field variable. This is the called as the primary, this is called as the secondary. Or directly we could say, whenever we are directly getting the value, calculating directly from the shape function or the stiffness function, that is primary variable, and which one are related with this primary variable, and later on we calculate the secondary variable, that is called as the secondary variables. So hope you are understanding from this chapter a very important concept of a of your study, because this is very important chapter, I feel. So let us move a revision, that is we are studying the displacement model, two model, that is the displacement and the interpolation function. This is depends on these two equation, that is the stiffness matrix and the shape function. Then then the coordinate system, what is mean by the three coordinate system: local, global and the your natural coordinate system. And finally the relationship. Here in this chapter we are trying to find out the relationship. This is the formula for finding the relationship between the local coordinates and global coordinate and the natural coordinate system. And finally the shape functions properties. And finally we studied the variables, primary variables and the secondary variables. Thank you for watching the video. Thank you.